Everyone, welcome to the Data Science Sunday. My name is Pablo. I am the host of the Data Science Sunday. This is episode 141, the 30th Data Science Sunday for the year 2025. How are we all doing? Welcome, welcome, welcome. Now, before I get started, first of all, apologies for starting out a little late. And it's not even on a serious note. We just had a few discussions before we jumped on. Um, Again, welcome. Today, welcome anyone who's new to the Data Science Sunday. Welcome every other person who has always been on the Data Science Sunday platform. Again, the Data Science Sunday is dedicated to anyone starting data science from scratch. It is a data science. It is a virtual data science community, and it is born out of the drive to build communities around tech skills. And building communities around tech skills is one of the pillars of what we do at Collab Innovation Hub. Data Science Sunday is powered by Collab Innovation Hub. Collab Innovation Hub is one of the first tech hubs in northern Nigeria. It is physically domiciled in Kaduna State, and we are building a tech ecosystem facing the world from Kaduna, Nigeria. At Collab Innovation Hub, one of our greatest pillars is community. We are building a tech talent pipeline. We're building a place for startups, a place for people seeking tech jobs, seeking tech solutions, folks seeking to build from scratch, folks seeking partnerships, seeking funding, seeking development growth, seeking advisory, folks seeking to build labs from the ground up in order to solve real world problems. That's what we're building at Collab, but we are humble enough to look at it from a community perspective, because community is a huge driver in innovation, in and for innovation. And to that end, that inspiration led me to jump on the Data Science Sunday, and we're here today. Now, the Data Science Sunday is on episode 141 since its inception on the 6th of November 2022. And so that tells you that we're building consistency here. So if you've been here since that time to now, we're looking at more than 240 hours of learning. Now, imagine if all you had to do was just come every Sunday and learn, right? So, but that's not the whole idea. The whole idea is that we can always wrap up our learning every Sunday and move on to the next week. And so that's what we do at for Data Science Sunday. And every week we try to bring in something creative to help every data science learner so that they can pick things up from scratch and run away with it. Right. So that's Data Science Sunday. Now, Data Science Sunday is a platform where we are spread into two sessions. The first session is from 6 p.m. West African time to 7 p.m. West African time. During this session gives us an opportunity to interact, ask questions, figure out, talk to folks who are here doing for the first time, or also listen to folks who are starting out stuff for the first time. Right. So that's one part of it. We also talk about what we've done for the week. There are folks who have challenges, folks who are trying to get started. And yeah, it's typically what we try to jump on. Then the second part of it, we also share links to resources, share links. We also share our challenges in the week and what we're looking for the next week. And then by 7 o'clock WAT, we start to have a technical session. In today's technical session, we'll be exploring handwritten digits, which is we'll be applying machine learning techniques on handwritten digits, which gives us the opportunity to see how this works. Right. One of the first things folks started to learn, or one of the first data sets we looked at were MNIST data sets. And for folks who started ML, or who have started ML and have seen the MNIST data sets, it's really intriguing to understand why it's that even used. I promise you, I hated it the first time I started, but right now I appreciate it a lot because it's a foundation for understanding ML techniques. Same thing with the Iris data set, same thing with the Titanic data set. They are all foundations for how we can pick up machine learning and then move it up to use it to solve real world problems. So today we're going to be looking at exploring those bits and digits. Then, so we started. If it's your first time on the Data Science Sunday, please feel free to share. If you've done anything this week you feel is worthy of sharing, please go ahead. And then while we are at it, I'll be sharing a few resources that I think would help. Today, I'm also going to introduce a new session. I started this session with our physical community, the Tableau Saturday community, where we learn business intelligence using Tableau. And that is, it is an idea founded on this concept that and it's not even a far-fetched concept, it's a serious concept. You cannot, here's my null hypothesis. My null hypothesis is you would not make a great data scientist or even any kind of tech person or in the tech field if you don't know things, if you don't know how things work. And so I'm hoping that maybe over a period, the alternative hypothesis, the HA, would not end up being what it is. But and this is me using some hypothesis testing analogies or jargon. But what I mean in essence is you need to know how things work. You need to know what's going on in the world. You need to know as things work, the intersection between the realities of life and technology. And I think we have a lot of learners in the space who are, they are knee deep in the technology, but know little or nothing about what happens in the world. And so what I do, or what I'm going to move from, what I've been doing in our Tableau community is we get to read an article, and in that article we see how things work. Shout out to the Statista guys. That's what I'm going to be looking at. So there are lots of ideas that come in, and the folks at Statista just write a little, they write something like a little article, and then explain certain ideas, and this ends up with a visual. So we're going to be looking at that during this session, because sometimes during this session, when we ask for you and we say, oh, why don't you go ahead and share, we don't always get these folks sharing. So I'm going to use that opportunity to talk about something new, and then we'll read an article presented by a data journalist, and then we'll just mull over the idea. And hopefully it will give community members an opportunity to pick up something, right? We have had really interesting topics like population, how the world's population is growing. The last time out, we talked about industrial robotics and the parts of the world where we have countries with that have the industries around robotics. So, and it will let you know that China has typically has the highest in it. I think they have over 276,000. Like we're going to read up on it, and you see how wild it is and how they man that industry. That's in Asia. Then of course there are the folks who are in Europe. I think that's Germany. In the Americas is obviously the United States. And it will surprise you how Mexico is also in the mix when it comes to industrial robotics and all. So we're going to read up about that. So I'm going to be having this session. I'll try as much as possible to make it such a short session, but it's a session where folks can pick up a little knowledge before we proceed. Again, I think it's an ideal thing for folks to know stuff. I feel like when we don't know stuff, then being maybe a data engineer or a software engineer or a data scientist or a machine learning engineer without this critical knowledge area, then it feels I feel it doesn't connect. I feel it's almost always important that we have this knowledge as we proceed before we go on to now do technical stuff, write code. It's ideal to know what happens in the world. So yeah, okay. So while we're waiting on that, if you're new on Data Science Sunday, please there are two things you can do. You can basically indicate like this, and I let you speak, introduce yourself, tell us what you're doing or what your challenges are, or you can use the in-call message here and just say hi and tell us what you do. Right. So please just use this opportunity to share. Additionally, if you've done something this week and you feel it's worth sharing, I think a lot of things are worth sharing. Please feel free to share. Hi, Shino, please go ahead.
Hi everyone. My name is Shino. I'm part of the community also at Dune Africa. That's Dune Analytics. It's a analytics tool for Web3 ecosystem. So I spoke actually yesterday. So when I said I was a bit having a lot on my plate when I couldn't make it to Tableau Saturday. So I spoke yesterday on Dune Analytics for Web3 startups, and I made mention of something we always talk about gaps. So when the reason why you have any product is because there's a gap somewhere in the market, or there's a gap somewhere that needs to be filled and the solution needs to come up. So part of analytics in Web3 has to also show that gap when founders are going to meet, because most of the time founders always get to meet or get to have a need at one point or the other in their journey to need funds from investors. So I just talked about what dashboards would need, what that would require for Web3 startups. So that's what I spoke about yesterday at the Dune Africa meetup. So that's how I rounded up my weekend. But I'm still on my sorry, I use that word web again. I'm still on my data learning on data camp. So I'm still doing the pack for Python on hypothesis. I started it previously, so I'm still on hypothesis in Python. So hypothesis testing actually in Python. So that's where I am. So previously I was on sampling in Python, but now I'm hypothesis in Python. So that's how my week has gone. Thank you, everyone.
Okay, that's awesome. Nice one. I hope there was a lot to learn in that space, and yeah, I hope there were a lot of experiences you were able to share with folks there. So well done. I'll talk about something as we proceed, but yeah, please, if you have something new you have done this week, feel free to share. If there's something, if you're new to Data Science Sunday, please feel free to share. While you are ruminating or marinating, I will share a few links that would help us push to Data Science Sunday stuff. First thing I'm going to share is first off, Data Science Sunday is streamed live. I think we've done that for the past 10, 15 episodes now. So it's streamed live, and it's streamed live on my YouTube channel. My YouTube channel is dedicated to anyone that is learning data science from scratch. So please feel free to check it out, and you can also use it to watch our other episodes. So please check it out. Data Science with Pablo. Like, subscribe, share with friends, family, and most of all your enemies. Then that's that. So are you new on Data Science Sunday? Please feel free to share. Another thing I'd like to share is I like to share Alan Downey's latest edition of ThinkStats, which is probability and statistics for Python programmers, especially for data scientists. If you're also someone looking to build data science, please feel free to check this out. I think it's good. I think it's great work. And he's put it out for free. So that is one thing I am super. I like that a lot. So you could check it out. Another thing I will share is I'll also share our WhatsApp and Telegrams group. The WhatsApp and Telegrams group is here. So I'll share the links over here. So please feel free to join. If you're new, please check out, join in, and we can learn from one another. Right. So I'm also going to talk about stuff today, which I think I have like 3 or 4 things to present, I think. Right. So I'm also going to talk about 3 or 4 things, and we'll work on that. So yeah. So if you're new and you're on the screen, you can see Shina did a presentation for Dune Analytics. That's Web3 analytics. They're building communities around Web3. I don't know if I've mentioned this. If you're in Kaduna and you're a Web3 head, you're someone who's interested in Web3, at Colab, we have a blockchain community, and not far away from Colab, there is also there is a hub dedicated to Web3 development, Web3 building on the Web3 space and all. It's called the Build, BUIDL. It's basically supposed to be Build, but well, we literally don't want to be doing all that, so we'll call it the Build. So please, if you're in Kaduna, feel free to check out the Build. It's something. If you come to Colab, just ask, where is the Build? We'll point you to the Build. The Build was founded and by also a Colab community member, so it's super huge, right? Okay, so that's that. So but in the absence of that, I also like to talk about a few things that happened this week. Again, we're in the final part of the data science mentor program, the final part of the data science mentor program. So yes, so you can see, if you see my screen, you will see that it's the data science mentor program. We are in the final part of this. For folks who are new to this, it's an accelerated learning cohort that I founded and I host. What I do there is I use data. It is mentorship as a service, and we have recorded sessions from Python to data science, data analysis with NumPy, data analysis with Pandas, a comprehensive data visualization package, and finally we are building on the machine learning. We have just finished the first introductory part to machine learning. Now we're doing a deep dive into machine learning. The interesting thing about the data science mentor program is you can always sign in at any point. We have live sessions, and if you're someone who is learning from scratch, you want mentorship while you learn. Sometimes folks are trying to pick up stuff while they learn stuff, and they just need somebody to reach out and say, oh, I'm not getting this correctly. So data science mentor is something. It's also a way for me to help folks who are learning. It's a thing. So feel free to jump on it and you sign up for it. And it's very, very helpful. Right. So really interesting stuff. I've noticed that the data science mentor basically help folks who are trying to upskill into data science, especially while they're doing either they're trying to get into their master's program and stuff. So really huge. There's data around it to support this whole idea. People who are trying to upskill basically jump on this, and it is virtual. it is all virtual, right? So you can do it from any part of the world. Okay, so that's one. So it's interesting. So if you check out my YouTube channel, we stream some data science mentor sessions. So you can check it out to see what it looks like and what the learning curve is like there. If you have a comment, please feel free to jump in and share some ideas you have there and all. Right. So that is for the data science mentor program. This week, or last not some weeks now, I have been doing something. I have thought I have this null hypothesis. I keep mentioning it. Shino says that he's learning hypothesis testing on DataCamp. I am too. This week I've been looking at statistics and probability for Python programmers and data scientists, and I've also been looking at hypothesis testing. And so the null hypothesis is basically, the basic assumption you have for something. So my basic thought or assumption is that if you don't really know, for you to make a very good data scientist, you need to know how things work. And how things work is in different areas. And to that end, because I don't want to be one to say, oh, look, a lot of learners in the data science space are not picking up skills, are not understanding how things work. I am going to start a session where we read up about something happening in the world, and we're going to read up Statista's newsletter. So just so you know, this is what it is. Statista. Where is that? Statista. So this is Statista. This is there's this portal for data research and all. This is it. And now if you sign up to Statista, right, like it says, they empower folks with data, insights, and facts across 170 industries. I think this is massive. 170 industries, right, and 150 countries. So you can see they've had recent topics on US tariffs, social media usage, e-commerce worldwide, AI, Netflix, global inflation, TikTok, electric vehicles, a bunch of stuff, right? Again, you can also check out Statista. You can put in your email and you can register here for free, and then with your email you can also get daily reports from the Statista team, right? And so with that, what I've decided I'm going to do is in the data science Sunday sessions, I'm just going to take a session and read up on something from Statista. For instance, this, right? So check this out. So this is today's session, right? And in today's session, we're going to be reading up on the golden visa. So today's conversation is going to be on immigration. Look at that. I think, and by the way, if you look at this on Statista, you see that it's reported by data journalists. That's Katarina Buchholz. What is this thing? Yeah. So she's a data journalist. And so we're going to read up on this. I think, and here's my thoughts, and I don't know, you guys are going to tell me what you think about it, but I think it creates room for a lot of conversations and a lot of areas where you can jump in and see stuff. And I think Statista does a great job with this. Folks at Statista, they do a great job with this. So without wasting time, I'm just going to go ahead and then read up on these articles. These articles are they're pretty short, but there's a lot that they talk about. So on today's topic, we're going to be looking at immigration, right? And it's called the golden visa, where you can buy residence permit. Now, also understand that part of the reason I'm saying this is I feel with Statista, they have a lot of topics. Just like whenever, just like I talk about SDGs, and I tell folks to focus on these areas, and that these areas are really important, like no poverty, zero hunger. Same thing I'll be doing with Statista. So we'll just basically run through this, and at the end of it, there's a visual, right? And then we basically I hope that when we're done with this, then it basically gives you a sense of maybe there's some information I've gotten today, and then we'll go on to look at the technical side of things. Now, when we go on to look at the technical side of things, it now means that we have built some knowledge, right? And if we've built some knowledge, that's really, I think it's great. So today we're going to be talking about where you can buy residence permits, right? In Nigeria, the Japa syndrome is a thing. People immigrate from Nigeria to the different countries. So I feel like this is really an interesting conversation. All right, so let's just get it over and done with and see what this looks like at the end of the day. So it says that after its unveiling in April and a popular waitlist launch in June, the Trump administration proposed golden visa program seems to be stalling. So apparently there's a golden visa program by the Donald J. Trump administration in USA. This visa program is called the Gold Card, and later the Trump Card. Isn't that not an interesting way? Like tongue-in-cheek, Trump Card. It promises U.S. residency to wealthy individuals for a $5 million investment in the country. Now, while Commerce Secretary Howard Lutnick announced the card will be made from real, all that glitters is not gold for the project that reportedly lacks legal grounding and faces on an uncertain future. So apparently there's a program, right, that is called the Golden Visa Program, either called the Gold Card or the Trump Card, right? And from the reports here, wealthy individuals who can invest $5 million in the US economy will be given the Gold Card. Isn't that interesting? Now, the President Donald Trump said in April on board the Air Force One that a launch was less than 2 weeks away. However, by the beginning of August, no news on the topic has been shared and no law has been introduced in Congress, despite 70,000 waitlist entries reportedly having been created in less than a week after the launch of trumpcard.gov. So there's basically this, which is that trumpcard.gov, on which I'll post this here. Who knows, there are folks who are here who are maybe an official website of the United States government. The Trump card is coming. Enter your information below and to notify the moment access opens. I'm interested. My email is Elsamit. Isn't that interesting? Right. So this is one. I promise you, like, guys, one of the reasons why I wanted this to be a thing is like it gives us a lot of information. And I think part of what I think at Data Science Sunday, having knowledge about stuff basically helps us become better. And to be fair, look at this idea, the Trump card, the gold card, right? So let's see. Now we'll proceed to say experts interviewed on the topic by CNBC have raised a legal concern surrounding the program. While Trump said he wanted to replace the current EB-5 program, which ties residency to the creation of approximately $1 million new business, this will require unlikely congressional approval. Another major issue is the US tax code that taxes global income, which is not attractive for immigrant investors. Trump said he wants this change, which again will be a major hurdle. At the same time, interest in the US golden visa is still very high, as several similar programs in Europe have recently shut down in Spain, Ireland, and Netherlands, while more were tightened amid government changes and criticisms of the concept. The US proposal has also supposedly received increased interest in light of Trump's threat to abolish birthright citizenship. Yet, another proposal merged in legal issues. On July 24th, a federal appeal court handed Trump a defeat in the matter, saying that the executive order on the topic was unconstitutional. Interesting stuff. So, so basically, this is what it is, right? Again, you can see, which I think is really important, say data by the law firm. And again, this is such an interesting thing. If you read stuff like this, it gives you the opportunity to read up on a lot of conversations around things like this. You can see, so here is a leading residence by investment program. So you can see the stuff that these guys do. Right. So they say shows that which golden visa or comparable schemes continue to exist for wealthy people around the world. Right. So I think another really interesting thing about this conversation is also the conversation around the sales of visas by certain countries. Right. There are countries that sell their visas, and you know, once they do, it's basically a huge stuff. So this is really an interesting conversation, which is in immigration, and there's data around immigration that you know, that you can want to explore if you're somebody who wants to look at the immigration side of things when it comes to data science and how to build around that. Then I'm hoping that conversations like this, you know, get you interested, you know, makes for a lot of stuff. You maybe want to understand stuff like the Schengen visa, what that means, right? You want to understand what it means for immigrants, right? What kind of program that is, right? And when they talk about stuff like as data shows, right? You want to know what type of data are they talking about. But like I mentioned, conversations like this, you know, I feel whets the appetite for folks who are trying to build on their data science careers, and something that will help you as you proceed. Right. Again, please feel free to sign up. There's a free spot. Again, I'm saying this, I'm not being paid to do anything on Statista. I just feel if you are someone that wants to build some skill, build your data science skill, or your machine learning engineering skill, or your machine learning skill, or your data analyst skill, I think it's important to have knowledge of something. And so today's session focuses on immigration. And my hope is maybe, just maybe, immigration, you know, piques your interest and you start to ask what is the data science application for immigration. Now, one final thing that Statista does is you know, putting up visuals, and these visuals are super interesting. For instance, the topic of this visual is the golden visa, where you can buy residence permits. Countries with residence by investment or similar schemes as of August 2025. And again, it's also another way for you to, you know, find out how you can build your visuals and see if the stuff the guys do at Statista makes a lot of sense, or if it's something you think, or maybe something else. You know, you can look at it from a different perspective. But here is their visual, and their visual here, you know, places a spotlight on investments in property or business. These are different immigration programs. Person of independence means, and business founders only. And you can see that the business founders is a huge space. You can see in North America, it's super huge for business founders to get you know, visas for being business founders. I think I know a couple of people who are on this setup here, like personal, right? And there are a few places too, very close to Europe, or even in Europe, that has that. And then it's also a thing in Australia. You can see that it's a thing here, right? And then there is also the investment in property, right? Or own a business or financial product or tax base. You can see that you can see some of it here. You can see that it's sort of like a thing in Europe, right? And it's even a thing in somewhere in very close to South Africa, right? And you see that there are places here where if you have investment in property, uh, it's pretty popular and becomes a destination. I think this is New Zealand. I think they do that too. And then also persons of independence means. Again, you can see very popular around here and here. So yeah, so again, like I mentioned, if you are someone thinking of immigration as an area of knowledge for data analysis, data science, reading up on these things helps. Reading up on it helps. And I think this is something I'm going to be doing randomly every Sunday. I'll just go to my email and look at the latest stuff that was shared. The last one that was shared is Asia, the World Robot Conference, where Asia's technology innovation is unrivaled. I think this was also really an interesting conversation. How when Asia leads in how Asia leads in industrial in the industrial robots installation. It's really massive. You can see Asia is the world's largest market for industrial robotics. It's 72% of all newly deployed robots installed there in 2023. It's wild, right? So I think this is it. Like China has more than 270,000 units installed in the country in 2023. And they also talk about the European market, with Germany being one of the largest market for industrial robot installations. Then in the Americas, it's the United States with 37,000 units installed, followed by Mexico and then by Canada. Right. So these things are really important to think about, right? If you another thing we noticed when we talked about stuff is you see in this whole place we don't have there's Africa is yet to come into this business. So the question is this an opportunity to jump on? Is that an opportunity to look at? So again, this is what I'm trying to I think is really interesting to look at. So yeah, so this is it. This is all I have to show today. Please, if you can, sign up on Statista, read up on different topics. This one is robotics and automation. The one we read today is immigration. So there are so many areas of knowledge you'd want to check out and read up on. And I promise you, it will really grow you as an independent individual in any tech space, be it a software engineer, a data scientist. The ability to know stuff is unrivaled when it comes to building your tech skill, right? I feel as if a lot of people have just tech skills or just technical skills, but they don't have the knowledge base for those technical skills. And for a large part of it, without knowledge base, you may not know a lot of things. And you might be building with really poor knowledge. So yeah. And this idea, I think, came to when we hosted like one of the five, I call it the five brains in the tech space in Nigeria. We had someone from Google who's part of the Google team with partnerships. We had Sanusi Ismaila, all in the space, Robert John, Adinoye Sadiq, a software engineer. We had Ifeanyi Mora, who is into school management systems and blockchain technology for finance. And these guys gave their ideas as all their experience. And one thing that came out of this conversation was you need to know stuff. You need to know things. You need to have knowledge of how things work. And that's how you try to build or solve problems. If you lack the knowledge on how things work, you eventually start to build, you start to build solutions that may not even help anyone. Or you build solutions that are against the law, setting law, or you jump into very highly regulated sectors to build, and you just lose your money and stuff. Or investors might not be even be looking at you, or you're building a tech skill in an area that may not really, have something going on. So yeah, so that's that for today. So guys, please, you can also give me immediate feedback. What do you guys think? Do you think having conversations like this is great for the community and for this, right? I think is super important. So please let me know. Anybody with an idea, anybody with a feedback on it, please feel free to share before we jump into today's technical session. Any opinions, anything you want to share? Yes, please go ahead.
Hello, everyone. My opinion is tied. Am I audible?
Yes, please.
Okay, my opinion is tied to something I read earlier today on social media, and it was somebody analyzing an interface for a product, and just like what you said, you don't bring your best when you don't have background. I think let's use what background knowledge first before we talk about foundational knowledge. So you don't bring your best when you don't have background knowledge on a particular area. So let's say with what we are talking about now, somebody is approached by a, I want to use the actual company now. Let's use the, okay, good. Someone's approached by a company that wants to go into not necessarily robotics generally, but probably robotic marketing. And you as either the dev or you as the UI UX don't have an idea of what's going on in the full arm of robotics, and bringing it down to we in the data space, it also falls on us too, that general knowledge is also required, because you won't always depending on how you are, either as a consultant or either as somebody in a particular space, general knowledge on what is going on globally will help you a long way to know what is the tick at either a particular point in time or during a previous decade or a previous how would I call it, previous century or a particular matter. So this information which you just talked about, getting to know what the data journalists are talking about is very important. I think what to round it up, just today I saw something on one of, since I follow one of these all the statistics handles on Twitter, and I found out that when you talk about knowing things, I always thought Motorola was a Japanese company. So just today I now got to know Motorola is a US company that started they'll be 100 years in 3 years time. And that's because I followed the statistics page that mentioned the year of founding of different companies. So just like you said, general knowledge of things that are going on with numbers to back them up is very good for anybody in the data space. And it's a good thing. It's a good thing you've started it already.
Okay, yeah. Thank you so much for that part. I appreciate that input. I think learning this stuff, basically taking your time out to read up on stuff like this, or just read up on things that happen, or maybe take a position or a stand on in one area, and maybe just get information, I think is super you. So thanks for that. Kabiru, please go ahead.
Good evening.
Good evening.
Can you hear me?
Yes, I can.
Yeah. Yeah. There's this thing called domain knowledge in data. If you've ever participated in any machine learning competition, you know that domain knowledge might be what will give you an edge over other competitors. So knowing how to code, how to manipulate your data is not enough. You need to have general knowledge about what you are working on. For example, you are working on data on health, you need to know a lot, let's say on diabetes, you need to know virtually everything about diabetes. So if you don't, your competitor, I mean, one of the guys you are competing with might just develop a feature in his data that will give him edge over everybody simply because he has certain information that nobody has about what diabetes is. So you cannot underscore the importance of general knowledge in once you are dealing with data. You understand? So domain knowledge, or whatever you want to call it, or general knowledge is very, very important in data analysis or machine learning or whatever you are doing with data. Thank you.
Yeah. I have a follow-up question, and I'm hoping maybe folks can think about this. Why do you think there's a reason why I think generally that there's this stuff about people jumping into the tech skill and not really placing focus on even domain knowledge or just general knowledge, right? Do you think, what's your thoughts on why this is happening? Or do you think it isn't happening? If you think it is, please, I'd like to know why are folks jumping into this space and really not caring about this, but just writing code and all? I'll be happy if you have an idea on this.
Well, it is not that they don't know that. It's just because some of them is the level they have gotten to in their career as a data person. That is why they don't know this. Like, for example, if you are at the level where you are just playing around with data, building small models, by the time you go to competition or you are competing with other data scientists or other machine learning engineers, you discover that is when you really know that at some point you have domain knowledge. Because if you don't, you can't win anything. You just discover that somebody, because he was able to generate a feature and add it to his data from the existing data, based on the knowledge he has about that particular domain, he wins the competition, and he wins thousands, sometimes hundreds of thousands of dollars. So I mean, when you see that, you know that you have to consider domain knowledge. That's why sometimes when I see people that are not in the health sector and training as health, they are training in health data, I begin to wonder, because if a medical personnel happens to be training, in data, as a data scientist under the health, of course, even as an analysis will be more in-depth than yours. So, and there's no way an employer will see a medical doctor or health personnel that's into data science and choose you that you are not in health sector over that person. It's not possible. So when you want to select a particular domain to work in, make sure it is an area that you will not be edged out based on certain qualifications you don't have. That is key. Yes.
Oh, thanks. One really interesting thing that happened this week was when we were having a fireside chat, someone talked about building a solution for cross-border payments using crypto, and he was part of the pain he talked about was getting people to get cross-border payments quickly and landing on the same day. And if you figure that's an area. So there were lots of things that were said about that. For instance, was interesting to hear folks say that like for instance, say cross-border payments means, let's say you're receiving money from the US and you want to get it in the same day. And then there was a question, someone threw a question and like asked, do you know why instant payments is a thing in Nigeria, but not a thing in the US or in some other countries? And it was an interesting question that it was interesting to know that it was something I had never really thought about. And that's why they hit me that, man, there's a lot that we rarely even read up on, right? And a lot of people are building payments solutions and they barely even know the reasons why certain things are the way they are, right? Someone came and said, have you ever wondered why the payment with crypto hasn't even worked in the Nigerian space? And have you tried to investigate why that is? Right. And then the person who was being talked about, typically, it was obvious that the person may not have known this information, but it was just those questions hitting the mind. It was just like, it was just like investors or stakeholders speaking to you, and you typically can't say much about it. And you're right about when somebody's in that space, and especially in the health space, you hear people say stuff like, I'm building my machine learning skills and I'm doing stuff with because it's predicting tumors and or breast malignant tumor and benign tumor. And when you ask, are you a health professional? So it's such an interesting thing, and that's why it's also part of the reason why I hope this part about sharing articles like this will get people to start thinking, maybe I should, if I'm going to be a data scientist on this, and maybe I don't have domain knowledge on it, I should start to read about it, which will give me some sense into what's happening in that space. So yeah, so guys, thank you for that. I appreciate that. So this would also lead us into our technical session of the day. And today, in our technical session, we are going to be exploring handwritten data. Now, why are we exploring handwritten data? We're looking at ML application, machine learning application. Now, before I get into this conversation, when I thought about this conversation, one of the first questions I asked myself was, what's up? Because every time you're learning, there's this machine learning thing going on. There's almost always the MNIST data set, the handwritten data set and all. And for me, I was curious, and I was like, what's up with this handwritten data set? And I pulled up a few stuff on it. And basically, there are interesting things. One, when we're looking at this, the MNIST data set or written data, right? Exploring written data. Is it called written data? Let me check just to be sure. Yes, handwritten digits, not written data. Apologies, guys. Exploring handwritten digits. Handwritten digits. That's what it is. Data, handwritten digits. Yeah. So and when the idea was, why was this such an why is this so popular in the ML space? And I was trying to understand why this is, right? And there were a bunch of reasons why it has played so much a huge role in and in ML education, data science education. And I just figured I share a few of them. One of it is handwritten digits is more or less like the hello world of machine learning. And it's seen as like the hello world of machine learning, and even deep learning, right? It's not the hardest thing in the world, but when you build on it, it helps you to look into advanced stuff. So it's looked as the hello world of ML and DL, which is deep learning. Hello world is the hello world of ML and deep learning. Hello world is of ML and deep learning. Another part is it's also seen. It's also seen as it's also seen that once you master this thing, once you can master manipulating this, it builds intuition for advanced problems. So it helps build intuition for advanced ML problems. Again, it's a gate. Also, it is a learning gateway for image processing, feature extraction, and the classification technique in machine learning. Yeah, because this plays a whole lot, right? There were also questions like why handwritten digits? And first off, there was the idea that it has this universality. Everybody knows 0s to 9, so it's easy to tell if the model worked or not. People write digits differently, so it was perfect for testing generalizations, which is, in fact, I think I should also write this. So so the question is why are handwritten digits a good starting point for ML education? So this was a very huge question. Why are handwritten digits a good starting point for ML education? So again, and one of the reasons which I agreed with generally was universality. Right? It's like everyone knows 0s to 9. So that's one. Everybody knows 0s to 9. So it's if your model works, then typically everybody can look at it and say, okay, this model works. Also, it's perfect for generalization. Perfect for generalization. When I say it's perfect for generalization, it means different people see digits differently. So it makes a lot of sense to use it to build your machine learning models. Another intuition that it has a small size. It's a small size. So it's pixels. So you can train, you can train the model. You can train the model without having a supercomputer. So that's another one. Another one is, I mean, it is solvable, yet it is challenging. So again, it is solvable yet challenging. So these are some of the reasons why we have. These are one of the reasons why the handwritten data is used basically. And so with this, I feel it's time that I jump into talking about handwritten data, exploring handwritten digits, and then using it to explore the learning of a concept or a technique in machine learning. Now, the one huge thing that machine learning does is your ability to make predictions. And to learn machine learning, it's ideal to use very simple yet practical ways of picking up the skill and finding the intuition that you can transfer into real world learning. And so to that end, it makes a lot of sense to work with data, and the handwritten digits typically help us do that. Additionally, it also helps us to connect with the realities, of understanding the estimator APIs used in machine learning. For instance, how to apply the use of the use of data representation with scikit-learn, and also these things help. And in a very quick fashion, where I'm going to basically walk through this, and then we can see how we can apply this as we go. So yes, a few things we're going to take away from this is writing the code as with respect to how it's the context, it's how you apply it to different contexts. If you haven't written code like this and understanding what it means, it's ideal that you pick up this way of learning, where we first off talk about the background to stuff, right? Then before we jump into it, because I believe that understanding the background to a lot of these things makes a lot of sense with respect to learning it, not just picking up the technical skills and running with it. Right. So the first thing we're going to do is we're going to load the email data. We're going to load and visualize the digits data. So that's the first thing, the first step we're going to do. We're going to load and visualize the digits data. Now here, what we're going to do, we're going to use scikit-learn's data repository, just like we have Seaborn's data repository. We're going to use scikit-learn's data repository for this. Now to get that, we will first load the model class, right? So here we're going to go from sklearn.datasets to import load underscore digits. So that's the first thing we'll do. So right now, this is now in our namespace. Now, the next thing we're going to do is we are going to look at digits itself that we're going to be working with. We're going to look at the digits that we are working with, and then we can start to make sense of it. Now, since we have digits here, the thing we're going to do is we're going to now put digits into. We're going to put digits into a variable, right? So we're going to call this digits. we're going to call this digits, and inside we're going to now load, because we have this already here. Sorry guys, my Illustrator, my annotator. Let me reload my annotator. Yeah, so we're going to load this guy. So here we're going to say load underscore digits. Load underscore digits, and we'll have this over here. Right, so this we have. Now, load underscore digits is, if we check it, we can just put a type and we'll see what it is, which is digits. And it gives me the sense that it's going to be a scikit-learn object, right? It's a scikit-learn object. And typically, the scikit-learn object means if I type digits dot, it's definitely, you can see the bunch of things we have here. We have the data, the description, the feature names, right? If we put feature names, you can see all it tells you. It's a feature names, and if you check them out, you can see these are the feature names, right? So, but what we are looking to use is the image. We're looking at the image. These are the images, and we can look at the images dot shape. And so you can see it's 1779, and it's basically is a three-dimensional data. So this is what it is. It's a three-dimensional data array, right? And so that's what it is, three-dimensional data array. And so we can look at it and see what it looks like. Because it's an image, it's ideal for us to visualize it, right? And then see what it looks like before we proceed with how we're going to work with it. Now, and again, today we might not finish what it is, but it's going to be an intro. Now, the next we want to do is to visualize the data, or to visualize the image. Visualize the image. Now, to visualize the image, we're going to make use of Matplotlib. We are going to make use of object-oriented visualization. Object-oriented visualization in Matplotlib means building objects as your PyPlot artifacts, and then you use that to visualize stuff. Now, we're going to do that and then proceed to visualize the data. I sort of feel like once we do that, I feel that is I feel that we've done a huge part of our learning today, right? So I start off by import matplotlib.pyplot. I'll give it as PLT. So we've imported that module. Now, during the data visualization session for the data science mentor, I did like a deep dive in data visualization, and the major focus was on Matplotlib, and that's where. So I think I'm fortunate to have a bit of knowledge about it and how to use Matplotlib to do a bunch of things, right? So we'll start off by creating two objects, right? Because it's an object-oriented way of visualizing data. We'll create two objects. The first is fig, and then the second is axis. Now we are now going to place figure and axis together, and it's going to form the foundation for building our for visualizing this image. We start off by saying PLT. Excuse me. We start off by saying PLT dot subplots. We're going to work with this because we are going to create a figure and a set of subplots inside of it. Now for our figure, we want it to be 10 by 10. We want it to be 10 by 10. Then and when we say 10 by 10, we're going to see what is going to be inside our what we're going to visualize, and you'll see the intuitions inside of it. And when we create the visual, now whenever we're building our subplots, we set up a tuple that carries the length and width of our visual. So we use fig size and put it inside a tuple and say this one's going to be 8 by 8 is the first. Now the second is we are going to set up our subplots, right? We'll call this subplot underscore KW, which is a parameter, and this parameter carries a dictionary. Here we have a dictionary here. Right, so it carries a dictionary. Now with this dictionary, we have the first thing we have is the key, this X ticks, and then it carries an empty list, and then we have Y ticks, and this also carries an empty list. Next, we're going to talk about grid specs. Grid specs basically is sort of like something that sets up the width, the height, and the width of our visual, right? So we'll just have to start with a very simple spacing for it. So we have grid spec. Grid spec underscore KW. And here we'll cast the H space, sort of like the height space 0.1 and the width space, which is also 0.1. And then we'll cover this. So we've created the first one. Now, what we're now going to do is we are now going to enumerate through these visuals. And remember, the visuals we're using is the data we're using is here. This is from the digits. Now we say for I, comma, at in enumerate. And then when we enumerate, what we're going to do is we're going to enumerate through this axis here. So we're going to enumerate axis dot flat. Right, so this is what we have here. Now, that's one. Second, we're now going to say act, which is this, dot show. It's like basically using image to display the image, and inside we're going to say digits digits dot image, because that's the image we want to visualize, and we're going to look at the image and reference it to the I here. Then we give it CMAP, which is a color map, and inside we'll use binary. Binary color maps are like black and white. Then we'll say interpolation. Not really sure what interpolation is, but it gives me a sense that interpolation is basically maybe saying how are the numbers we have going to be, right? But here is nearest, and then that's that. And then next we're going to now say act.text. Now we say 0.05, 0.05, which my assumption is that the 0.05 basically states the size of the text we're going to be working with. Then we now say digits. We have digits dot target. Digits dot target, which is here, because our data, this data here, this digits data you see has a lot of things going on with it. I showed you here, we have the digits itself. We have the digits, so you can see. In fact, let's look at the target names. If you look at the target names, you see that the target names is 1 to 10 and 0 to 9, because it's images we're looking at, right? So we have digits dot targets, and yes, it's basically what we have here that we should be in here, and we'll enumerate through them using what we have in here. Then we should close this. Then we should okay, let's say then we can have transform, and transform is act dot trans axis. Then color is equals to green. I think this should basically be this. I hope. Okay. I hope this works. All right, so let's visualize this and see. I knew something interesting was going to happen here. One digits that's target. Okay, this is this. All right, so let me see. Okay, so it's supposed to visualize. Attributes image. Where's that image? There's an error here. Digits dot image. It means there's nothing like this. Digits dot image. Digits dot image. Hold on, guys. Let me see. Digits dot image. Digits dot image. Oh, sorry, there's digits dot image. Digit dot images. All right. Okay, this should work. Okay, so now let me see plt dot show, because it didn't show anything. Okay. This is interesting. Okay, let me call this again. So maybe I've done it before, so it will just show the image. It doesn't. Okay, so let me run this again. One. Waiting, then show this. Right. So this is what we have. So this is what the image is. So this is what we've been trying to visualize. I think this image looks really weird. So I think, okay. Sorry guys, let me check out my notes before the class. Sorry, just a bit. Oh, I see something. I see something. Yeah, so these digits dot target, they are numbers, right? But they are, oh, I see. Let me see, string. I'll convert this guy to a string so that they can come out as string. So that means I can now close this place. Then I'll draw this. What have I done? And I run this. Then I run this again. What's this going to show? I figured that by putting it in a string that it will basically make it put square brackets into it, but apparently it did not. It feels like there's something I'm missing that's not putting it into perspective. But basically this is it, right? Yeah, so this is it. This, I hope also that it is not, I mean, it may not be that it is using maybe a background that I had set initially, but I did not set any background initially, but again, here it is. We have our visuals of this, but again, I think something is wrong somewhere. I feel like the images are not spaced correctly. I feel so. I feel they're not spaced correctly. Maybe there's something I am missing out on that's making them not spaced correctly. But whatever the issue is, this is what we have. So this is it. These are the numbers we have. You can see that every number here has the number all written down here, so that it could make it makes a bit of sense what the number we're dealing with: 0, 0, 2, and all. Now, the reason why we are having this data is because we want to apply something called dimensionality reduction technique. Now, to apply dimensionality reduction technique to this, it only makes sense. So now, dimensionality reduction technique, which is an unsupervised learning technique, is telling us, since our data looks like this, can we convert our data into a lower dimension, right? Then that can now tell us if there's something really interesting about the data we're looking at. So with dimensionality reduction technique, we are trying to see our data differently, right? And when we see our data differently, we might gain some insights when we see the data very differently. That's just the idea. And now one technique for that is the sklearn manifold, the sklearn manifold class. So again, if we come over here and I check sklearn.manifold, this is it here. Is an approach for non-linear dimensionality reduction. An algorithm for this task are based on the idea. Let me read through it. Where did we see that? Yes, an approach, an algorithm for this task are based on the idea that dimensionality of many data sets is only artificially high. And you can see we are using this. You can see that we're using this guy here, right? So now the idea is, can we create sort of like a different dimension that makes it easy for us to view this data and see it in a different dimension, but at the same time gives us some insight, right? So that is what we're going to do. And to do that, I'm going to basically do that really quickly, right? I'm going to do that really quickly. First off, before I do that, it will be ideal for me to convert my data that I'm using to do this into a data representation that makes it easy for me to visualize a scikit-learn estimator. I've mentioned this before, right? So the first thing I'm going to do is, and remember, the whole idea is to convert it into n samples and feature matrix. So here I'll call this data representation for scikit-learn. We've learned this before. Data representation for scikit-learn is important to know when you're trying to visualize your data to that, and which means it must be n samples, comma, feature, n samples, comma, n underscore features. So what we do is we say x is equal to digits dot data, and this digit dot data is the first part of it. So if we check x dot shape, you see that it tells us n samples, n underscore samples, and here it tells n underscore features, right? 64, right? So because it's, you can see it's 8 by 8, 8 by 8. That's what we have here. Then again, we now have to look at the y, right? The y is supposed to just be n samples. So we just say digits dot target. So this is what we have. And the target is definitely going to be y dot shape. And you can see that it's this. So now we have set it up to look like this. Now, what we are going to do is we have a 64-dimensional parameter. So this is what we have. We have a 64-dimensional parameter, which is here. We have 4-dimensional parameter. And so what we want to do is, this is 64-dimensional parameter space. And but what we're trying to do is to visualize it, and it's in such a high dimensionality space. But we want to reduce the number of dimensions so as to see if we can basically see what is here. So we will use the dimensionality reduction technique. The dimensionality reduction technique, right? And to do that, we're going to use the isomap. We're going to use the isomap algorithm. The isomap algo. We're going to use the isomap algorithm to do this. All right, so remember, first things first, we call from sklearn dot manifold imports isomap. This one. Second, we're going to have a sensible default. So we say ISO equals to ISO map, open brackets, and the sensible default is n components equals to 2. So we're going to do 2 dimensions. Then second, we produce sensible default. Then we go on to fit our data. So we say ISO.fit. And the data we are trying to fit in here is going to be we're going to basically fit the digits data. Then when we're going to fit the, we should fit the digits data. Yeah, we can fit the digits data. Then we will now project the shape of the data first. Then we'll go on then we'll go on to transform it and see how that turns out. Then we'll later do this, then later see how we can also use this data that we have converted here, this X and Y that we have, to do other things, because this is important, but it's for another stuff. So here we're going to fit the data we have. We're going to fit this data here and fit digits.data. Right, we're going to do that. It fits this. Number 1, the number of connected components of the neighbor graph is 2, greater than 1. Completing this graph to fit ISO map might be slow. Increase the number of neighbors to avoid this issue. Increase the number of neighbors to avoid this issue. Changing the sparsity structure of the CSR matrix is expensive. Leo matrix is more efficient. We'll deal with that a little bit. Let me just put the other one. So this, I'm going to write data underscore projected. And data underscore projected is equal to ISO dot transform, because this mostly when you're dealing with unsupervised machine learning, most times you're like basically either transforming the data is also a way to do it. It's not almost always predicting. Maybe you can also transform. So we're going to transform the digits data. Then we can now print projected data projected, and if it works as so, it's going to convert it from 64 to, it's going to, you see that it's going to make it 2-dimensional. So if you look at the shape here, it's going to be 2-dimensional form at 64 dimensions. So this is it. So the next thing we want to do is to visualize it, and visualizing is super important, right? Now, guys, let me tell you something. I like the fact that we're having all these warnings, and so when we finish, I'll try to clear up this warning. So these warnings are also important, right? And so we'll clear up these warnings because warnings come up, and that's because there's been changes to it. Now, let's also go. So here, let's do a visualization of this. So we start off by doing plt.scatter. So now plt.scatter is a MATLAB style for visualizing stuff. So you typically don't need to create objects for it. You can just on the fly visualize stuff. So I say data projected, data underscore projected. And here I want to deal with the first dimension, right? And then here data underscore projected, and I want to deal with the second dimension. Then C will be equal to, which is like, it's basically like a color, basically, and say it will be digits.target. This is going to be digits.target, right? Then we are going to have edge color being equals to none. We're going to have alpha, so we are going to have some 50% transparency. We're also going to have a C map. Again, I like this part. When I was checking out some stuff about it, I'm going to run it, and you're going to see some code has deprecated from the earlier code that has been written. So I'm going to write, this was how it was written before, plt.cm.get_cmap. And here we're now going to use call this varieties, right? Call this varieties and comma 10. I'll close this. Then I'll go on to say PLT dot color bar, and then here we're going to say label is equal to digit label, digit label. There's a color that will map to that, and write x is equal to range open bracket 10, and I close the brackets. Then PLT dot C limits, and here we have minus 0.5 comma 9.5. This tells you the range of the numbers we're looking at. Then we go on to say PLT dot show. Now, so we visualize this, and so you can see what we have here is basically looking at the numbers that we have created. This is the number we have created, and we're now visualizing them. You can see, so now this number has been put into different dimensions, with the different colors here being the digits, right? So it's now in 2 dimensions, and we can now see the different colors depicting different numbers. Like if we look at this very interesting number here, it's supposed to be the 9 of it. If we look at numbers like this, you can see the darker one tells these are zeros. Interesting stuff, right? Now let's revisit something. Now remember, here earlier on we had this. Now the number of connected components of the neighbor graph is 2, greater than 1. Now completing this graph to fit ISO map might be slow, so you have to increase the number of neighbors. So basically, if we come over here, there should be a number of neighbors. Yes, the n neighbors by default. The n neighbors is by default. The n neighbors is 5. So increasing this n neighbors, which is n underscore neighbors, to 10 will take out this stuff we have over here. So for instance, if I run this, and run this, this takes away, this should take away the error. So you can see that the error is out. So it sort of makes it faster for us to typically work with and visualize. Then over here, the change here is there's been a change in the way the code here is written. If you're calling CMAP, there's no need to add all this, because this is so much, right? So a lot of changes have been done. So basically, you just say CMAP and you drop only this here. So you can see a lot of changes made to this, which makes this better. You just basically say CMAP and write varieties. And so again, if you now visualize it, you can see that now this basically looks different. So this is typically looking at all our numbers, right? So you can see our number here. Now all this have been broken down from 64-dimensional space to a 2-dimensional space. And with a 2-dimensional space, we're typically trying to see if we can visualize the numbers we have. So you can see the numbers. The numbers are based on the colors, right? Now, imagine having so much data and then trying to compress it 2 dimensions to see if there's some kind of some insight you can get, right? Maybe it could be spatial data and it's all over the place, but maybe you want to get different areas or you want to view them in a different way. So again, dimensionality, this again, one of the reasons why I introduced why the MNIST data set is used is because it sort of gives us a sense of something we all know. Fundamentally, we know 0 to 9, right? And then to test the idea of dimensionality reduction, using 0 to 9 as a a way to check the different dimension, makes it pretty easy, right? So this is what it is. If you have any questions, great. It would be great to fill it now. If you don't, and all these things looks fuzzy, please remember you can always watch it again because it's live on my YouTube channel. So yeah, Shino, please go ahead.
Okay, because the time has gone, I would just want you to drop the notebook on the community group.
Sure.
Thank you.
All right, guys. Again, just to recap for today, interesting thing we talked about today is domain knowledge. Basically, Kabir wrapped it up by saying domain knowledge is so important in any space where you are. So please, you know, make it a tradition, make it a culture for yourself as learning data science to pick up a domain knowledge. You can do it by reading articles around certain things. I talked about reading this. I introduced this in our Tableau Saturday. You can just sign up to Statista. There's a free version. You get newsletters and articles. And these newsletters and articles reference certain areas. So there's immigration. We looked at there's robotics and automation. There are different areas you can look at, right? But remember, understanding, having this background knowledge is important and it helps you it gives you a competitive edge, right? All right, so guys, this is it for the episode 141 of the Data Science Sunday episode, right? Data Science Sunday session, episode 141. This is the 30th Sunday. We're just wrapping up the 30th Sunday of the year. Right, so please feel free. I'm going to drop this notebook in the channel, in the community channel, WhatsApp and Telegram. Please feel free to jump on it and walk through it and all. Also do a research on how ISOMAP helps and in their use cases. If you can write that up on a generative AI tool, right, to give you an outlook on what ISOMAP does and dimensionality reduction does. For real world use cases in different areas. Also, the area that you're looking to build your domain knowledge in. So, yeah, so that is that for today. Thank you so much for being a part of this. I appreciate your patience. And yeah, that's that. So thank you and all the best. Again, remember, a new week, new opportunity. Keep learning, and I wish you all the best.